we have to be comfortable with the fact that maybe when we study the abyss, it studies us back.
On this episode of American Alchemy, we meet a 26-year-old whose name is Deep Prasad, reverse engineering UFOs using quantum computers. And he's raised $15 million for his startup, Quantum Generative Materials, to do just that.
There are too many anomalies around the world for us to ignore.
So now you're probably asking yourself, how the hell do you reverse engineer materials that you don't even have access to? Well, luckily, the Pentagon has hundreds of instances of optical, radar, and infrared detections of UFOs. And from those records, the DoD has laid out 5 observable properties that are very consistent among the UFO sightings. These are things like sudden and instantaneous acceleration, hypersonic velocity with no signatures. All of these are properties that, as my colleague Eric Weinstein loves to say, exhibit wholly new physics, not just new engineering.
If we're taking visitation seriously, it almost certainly means that Einstein isn't the last word gravitational.
To me, immediately I realized that's not your average macroscopic interaction.
He thinks that the 5 observables point to UFOs engaging in quantum macroscopic behavior. So what exactly do I mean by that? Quantum physics generally governs the properties of the very small. Things like atoms, photons, and electrons, tiny elementary particles that do spooky things like entangle at a distance, tunnel through physical barriers, and sometimes exhibit wave-particle duality. Similarly, Deep believes that UFOs could simply be large macroscopic quantum objects.
What's to say that what we're observing now today with UAPs aren't just materials, more advanced materials than we have access to today, whose emergent properties we just can't model with today's physicists and mathematics, right? But imagine if you have a computer that's doing it, a quantum computer with a much more powerful brain than any other human on the planet. They may be able to figure out what these materials are.
So strap yourself in and grab some salt because your brain is about to be scrambled by the master quantum chef himself, this week's American alchemist, Deep Prasad.
Different parts of the brain have different activities.
But you know that, don't you?
Maybe you should interview me.
Why don't academics in Silicon Valley, serious high-functioning people, why the fuck don't they take it more seriously?
Yeah, there's just so much social pressures basically deterring people, even highly intelligent people, from wanting to study this subject.
I'm here with Deep Prasad, who is 26 years old. He has a quantum computing startup, but part of the mission of this quantum computing startup, it's actually reverse engineering UAPs or UFOs based on their observable properties. In some sense, the most interesting starting point is like, how does one get into both quantum computing and UAPs?
It completely blew my mind that the technologies, the observables, and what was being reported, there was no way, in my personal opinion, that that could be a derivative of any human science. So you have hypersonic velocities, for example, right, with no signature.
Oh my gosh, look at this thing. They're all going against the wind. The wind's 120 knots from the west.
As the waves get created around your craft, the waves at the beginning, the sound waves at the top, will get bunched up and compressed. And that's the sonic boom that you hear. So when an object can travel at greater than 5 times the speed of sound, like the tic-tac, which is estimated to reach at least 31 times the speed of sound, and it doesn't disturb the air around you, to me, immediately I realized that's not your average macroscopic interaction. So the physics that we use to describe macroscopic bodies no longer applies to these things.
Like my colleague Eric Weinstein likes to say, this isn't new engineering, it's new physics.
Correct.
The role of aerospace companies as holders of potentially basic scientific knowledge not shared with the academic world seems very wrong to me.
Maybe wrong, but it's true.
It is true. You believe it's true.
Yeah, I know it's true.
You know that there's physics knowledge held by aerospace companies that is not known?
There certainly is materials knowledge, which involves topological physics.
Eric and I had a pretty trippy conversation with the guy that briefs all of the presidents on UFOs, a guy named Hal Puthoff. For more of that conversation, you might have to wait a couple of weeks, but let's get back to Deep. Okay, so how does this relate to your interest in quantum computing?
You know what, let me give you an actual example and why this might apply to UAPs.
Yeah.
So let's rewind to 1911. Because we can never ever observe absolute zero, we should never be able to observe exactly zero resistance. And in 1911, when Dr. Ohms discovered the first superconductor, it blew everybody's mind because this was supposed to be thought impossible. And 40 years later, we finally understood why this was even possible at all. And we learned that it's because of quantum mechanics. That quantum mechanical behavior occurs at the macroscopic scale, and that's what we're observing. And it only applies to, keep in mind, low temperature superconductors. We still don't know how high temperature superconductors work. We know that it's some weird quantum phenomenon, but we don't have the physics and perhaps mathematics to describe what's happening there, or the computers. So what did we learn in 1911? We learned that when a material breaks the laws of physics, when anything does, it's actually probably because it's an emergent property or an emergent phenomenon, right, of underlying strange quantum mechanics that are going on.
Okay, so you're looking at properties of UAPs, things like, hypersonic travel with no signatures, or breaking conservation of momentum. Right. You can't make that work in sort of our classical physics or aerospace abilities. So you have that, and then you have this interest sort of in quantum field theory. How does this relate to quantum computing, and how do you tie it all together?
So look, when I first started in quantum computing, my goal was to be able to simulate any new material and predict it before having to make it in the lab, right? I wanted to be able to tell, is this new combination of atoms going to be the next semiconductor? Will it be the next solar cell, the next batteries?
That's cool. So you wanted like the ultimate modeling software or something.
You got it.
Like what Tesla could do in his brain.
But true.
And you would be able to do that with quantum computing? Or?
We will. Oh, absolutely. Here's why.
The classic equation that we'd use to simulate the properties of atoms would be the Schrodinger's many-body equation.
If you can solve that many-body Schrodinger equation, you will know everything about that material. You will know the speed of sound in that material. You will know its resonance frequency. You will know its heat capacity, its strength.
The problem is that in the past, we haven't been able to do this equation for more than about 3 atoms.
Yeah.
Not much. It's not very useful, right?
In other words, the many-body equation has a scaling problem.
As Paul Dirac said, he literally said, everything we want to know about materials has been figured out. We just don't have the computational resources to solve this equation.
Deep thinks that the bottleneck for solving this equation at scale is basically just using classical computers. And with quantum computing, we might actually be able to do it and simulate metamaterials that exhibit the 5 observable properties of UFOs.
We engineer every technology today, and in the sense that we treat quantum effects as a side effect, an artifact, a consequence that we have to engineer around. Quantum computers, they take a different approach. They say, instead of treating quantum effects as this unwanted thing that we're engineering around, right, and incorporating accounting for, let's actually leverage it. Let's create quantum systems of our own and manipulate them so that we can simulate other quantum systems. Because in order to simulate nature, and nature is quantum mechanical, you need a system that is also quantum mechanical.
The quantum mechanical world is like a dream world. Powerful and ethereal, anything can happen in it. However, as soon as somebody on the outside disturbs you, you wake up and all you're left with are memories. Similarly, subatomic particles exist in a probabilistic state of many possibilities, but when they interact with an observer, they collapse into a single state. As a result, quantum hardware, which relies on maintaining 2 or more states in quantum superposition, will decohere if they're interfered with by anything from the outside. This is the main bottleneck for building fully fledged and functional quantum computers. They're incredibly sensitive, and they often require very specific and energy intensive environments in order to maintain coherence. This is why initially Deep is using a quantum computer simulator instead of quantum hardware.
All quantum computers, the algorithms that we're running on them, they are universal computations. What that means is that we will be able to model any algorithm we want on quantum computers. And so what we can do is, if you're smart enough, if you're clever enough, you can figure out the right mathematical representation of the many-body Schrodinger equation and port it onto a quantum computer simply by the fact that you can approximate any algorithm you want on a quantum computer. So if you have algorithms and mathematical models that map, right, from quantum computing to many-body Schrodinger equations, you're in the money. And that's what we do, right? We do hardcore research into how to map these material science problems onto quantum computers.
Describe to the audience what a qubit is.
It's the quantum version of a bit. A bit is the fundamental unit of information for classical computers, right?
1 or a 0.
1 or 0, exactly. But the fundamental smallest unit of information you can have in a quantum system is a qubit. Qubits can take on superpositions of states, right? And so what a lot of people in popular culture, popular science butcher when they describe superpositions is that they say that the qubit is both 1 and 0 at the same time. That's not true. It's not in the 1 state. It's not in the 0 state. It's not in the 1 and 0 state either. It's also not in the 1 and not in the 0 state. It's in a superposition state.
But how does that equate to transmitting
More information.
More
so on.
information, yeah,
So
exactly.
if I were to have, let's say, just 10 bits, right? It sounds trivial, but it takes 10 bits to describe the state of 10 bits, right? But if I have 10 qubits, then I need 2 to the 10 classical bits to represent the entire quantum state of those 10 qubits. Because you can have all of the qubits entangled with each other, meaning that they can all, to describe one, you have to describe what's happening to all the others. Take a caffeine molecule, right? The caffeine molecule is estimated to have about like 97 electrons, right, at least. And to describe 97 electrons, fully entangled 97 electrons, right, to properly account for that, you would need 2 to the 97 classical bits. And that's more atoms than the surface and all of planet Earth, right, minus the air. So even if I took every single atom on planet Earth and converted it into classical bit, I wouldn't be able to store the quantum state of a caffeine molecule. For some reason, nature is able to do a level of bookkeeping in the background with quantum states that we don't fully know how it does it. Nature does this bookkeeping that's so computationally impossible for us to do today, right? And that's where like ideas of the multiverse and multiverse interpretation comes in and so on.
Right.
Where people will say, well, nature's not actually storing it anywhere. It's actually just distributed across different universes.
We have a sense of where it gets stored. So obviously,
but these are
there's
just
a way in which
guesses.
quantum computing sort of simulates nature more accurately, and so it can store
Exactly.
more. But do we have a sense of how the computing is storing either, or that's also somewhat of a black box? Where
Complete black box.
That's
we
pretty
can
crazy.
engineer them.
Interesting.
But we have no fucking clue why it works.
Wow, that's pretty nutty.
Every physical material ever is a quantum system. Your brain, your skin, everything is made of atoms, and all atoms are described by quantum mechanical rules.
It's almost a form of blind exceptionalism to say that the body is not quantum, because everything else is quantum.
True.
So then how much quantum sensing is going on, that's unclear, but
Exactly. It's not like we came into existence as giant macroscopic bodies, right? We literally started from an amoeba. We were closer to the quantum scale when we started out. So it's hard to imagine that we didn't evolve, even at the cellular level, some ability to use quantum effects, for sure.
do you think your brain is a quantum sensor? Like the Penrose argument would be, so it's like we don't perceive anything kind of in its quantum form. Obviously we perceive, a bigger proportion kind of classical stuff.
Right.
And the Penrose argument would be that, you have a probabilistic universe, you have Schrodinger's wave equation.
Right.
And we're collapsing Schrodinger's wave into a specific eigenstate,
Right.
Using this some quantum sensor in our brain, maybe microtubules or maybe something else.
Right.
Do you believe that, or?
The thing is that with our brain, there may be parts of our brain that could behave like a quantum sensor. We know that there are birds that can navigate the Earth's magnetic field and
Yeah.
can sense it, right, using quantum sensing, essentially biological quantum sensing.
Yeah.
The body and biology at large is typically warm, wet, and noisy, not conditions that you think of as conducive to maintaining quantum coherence or exhibiting quantum properties. But scientists now know that there are actually parts of biology that do exhibit quantum effects. For example, there are birds called robins that have a specific protein called a cryptochrome in their eye, called CRY4 that actually uses quantum effects to sense the magnetic field of the Earth. Electron pairs in the CRY4 protein arrange themselves based on the robin's position and direct the bird where it needs to go based on the magnetic field of the Earth. It's basically biological GPS.
Lockheed observed these birds, right, or like the physics, and they decided, can we replicate this with existing sensors? Can we create a quantum sensor that does the same thing that these birds are doing to detect the Earth's magnetic field? And they succeeded. As of 6 years ago, they created what's called a dark ice magnetometer. So with these magnetometers, they can navigate anywhere on Earth without a GPS, with GPS precision. They don't need a satellite. They can be underwater, they can be wherever the hell they want. And they can...
That's pretty amazing. Well, there are all sorts of national security vulnerabilities with GPS satellites.
For sure.
And then if you don't have access to GPS for whatever reason.
And imagine if you're an extraterrestrial species visiting a new planet, you don't have access to GPS. How are you going to map their field?
Magnetometer, that's it.
As we build more powerful quantum sensors, we're going to be able to learn things about the human body that will actually be medically useful. There's already research being done and devices being built for sensing the heart and like the activity of each, basically atom in the heart, right? So imagine having atomic resolution into the human body.
Wow.
This is what's going to happen, right? It's inevitable.
You see all of LA, so that's West Hollywood right here, downtown all the way east right there, and then you can see the beach during the day all the way west.
God.
Yeah.
It's beautiful.
I think your blog is fascinating, and I want to go through some of your blog posts because I think the titles themselves I think are worthy of explanation. So I'm just going to go through a couple of them, and you can sort of give me the summary if that works.
Sure.
Okay. The evolution of science and the interactive universe.
So when we look at the modern scientific method, right, it was invented by, the credit goes to Sir Francis Bacon. His assumption, the scientific method naturally assumes that whatever you are deriving about the universe should be repeatable, right? And if it's not repeatable, if it's not testable and controlled, then it's not scientific and it's not useful information. The issue with that is that it assumes that the universe is static, that if I were to measure a certain volume of air, that it will never change. If I measure the particle composition of this air, nothing ever changes. The repeatability is there because the laws of physics are the same and so on and so forth. Nothing will ever affect my measurements other than the errors that I already know. The fundamental issue with Sir Francis Bacon, his assumption, was that as Commander Fravor flies through the air, that air, the composition, everything about it should be repeatable. However, that day, something happened that was not repeatable, the existence of the tic-tac. So somewhere in that air was this anomaly, this thing that does not and is not repeatable, yet it was clearly something that needs to be studied. So the scientific method needs modification, and that's what this article is about.
Another model of science, and this is maybe like a Kuhnian model, is that there are anomalies that don't go explode. Like we were talking about quantum field theory, like you had black body radiation in the 1860s. Discovered by some German guy, and it didn't make any sense. You'd expect sort of runaway heat in this black body or whatever, if you were talking about kind of a typical Newtonian system. And that wasn't the case. We figured out mathematically why that wasn't the case when Max Planck figured that out. That light was actually quantized in the early 20th century. But you have these things where it's like little pokes in the formal convention of the time and the standard paradigm, and you're like, what is that? Doesn't quite make sense. It doesn't quite make sense. And I love that there's a Karl Popper line. It's called Materialist Promissory Notes, and it's all of the gaps of materialist reductionism will get filled in inevitably. Exactly. But that in itself takes faith, and so I think studying anomalies is incredibly important.
Absolutely.
And should be seen as possibly a harbinger of the next paradigm.
Absolutely.
And not shoved away, and not. I mean, I think we're over-indexed on like people like Michael Shermer, like justifying the current paradigm. That doesn't move science forward. That's not exciting at all.
It doesn't. It also doesn't face reality. I really believe in, as cheesy as it sounds, facing reality. If we're realizing that the scientific method is not giving us the full picture, we should be looking at new methods too that complement, right, science as well. Because we know now, or at least no, we have good indications that the universe is indeed not static. As in, if I were to measure something, there is a non-zero chance some crazy anomaly that has never been properly categorized will occur in my measurement, in my experiment. And we need to be able to quantify that somehow, and we need to account for it. We have to be comfortable with the fact that maybe when we study the abyss, it studies us back.
One of the interesting things we've been talking about, like physics with UAPs, but what I find very interesting is if you look at all into the subject, it's not just new physics, or if it is new physics, there's one component that doesn't fit with our current model of physics outside of the observables of the actual UAPs being very weird, and that's that certain people see the UAPs, and those people see the certain UAPs often in various states.
True.
And so, again, the Occam's razor easy way to explain that away is the person is crazy.
Right.
But often these people have no mental health history. Why do you think certain people see UAPs, and is there science that we'll discover that might be able to explain that?
I have two answers, right? One is much more rational and doesn't make me sound crazy. The other one makes me sound like a complete lunatic.
Let's start with the second one.
Okay, sure. My lunatic answer is it's based on cellular automata. So cellular automata is a notion that comes from computer science and mathematics, and it's the idea that you can create highly complex, highly emergent systems from very basic cells and very, very basic rules, right? Where you just define, a couple cells on a grid and how they'll behave, whether they die or not, right? And this is where like Conway's game of life comes and so on. And then we see that if you let the simulation run and you let it play out, you imagine you see this completely different emergent phenomenon, right? That's so complex. My crazy theory is that these UAP sightings that we're seeing and so on are part of the cellular automata, where individually they may seem like one-offs and weird events, but what we're experiencing could be part of this essentially game or strategy where the end goal is this very, very complex emergent phenomenon that cellular automata leads us to. And I think that we're part of a more intelligent organism's cellular automata game, I guess, if you will.
Interesting.
I think that it's the whole point is to change society towards a new state, an emergent property, like a very complex society that we don't even have, like we're not even near right now. Like we're getting pushed towards it in ways that we don't even realize.
That's what's weird, is it almost feels like there's an arc of tech innovation or civilizational progress or something that it's like, why are there certain discoveries at the same time in places that didn't have any contact with one another, or people were having sort of the same thoughts at the same time? There's obviously esoteric traditions of kind of cyclical civilizations that rose up and then they declined. And I don't know, it's all very hard to explain, but maybe tech is more preordained than we think it is. Or maybe per like the William James transmission theory of consciousness, these things are sort of zapped into us. And all ideas are kind of zapped into us. Okay, let's go through some more blogs. We have resolving key issues in quantum mechanics while simultaneously debunking every UFO case in history.
I love that.
What is that?
Yeah, so that was just an April Fool's prank.
Oh, okay. Curiosity as a time capsule. What is that?
Awesome. So that's where I lay out my predictions for where I think UAP research is going. That was my version of a time capsule, so that one day the hope is that 5 years, 10 years, 20 years from now, as we develop a deeper understanding of what UAPs are and the ecosystem around it, what it means or where that's going to leave us. So that's what that.
What are your predictions?
My prediction is that over the next 10 years, I think that we will have collected enough scientific evidence, enough groups will have collaborated and worked together, and also post-scientific groups too, right? Like I mentioned, we make some modifications to scientific method. I think that we're going to be a state in a decade from now where we acknowledge that we are not the only life forms that are intelligent and super intelligent on this planet.
I vaguely
Set myself
believe
up for
that.
failure.
Yeah, and that would be an insane thing. Say we all were like, okay, so we have scientific verification that aliens are, have
Right.
bases somewhere, whatever.
Right.
All of a sudden, you replace angels and demons in the Bible with aliens, and you're like, okay, that was probably real.
Right.
And like a lot of that stuff might be happening now, and actually my cousin who had a vision, or whatever, like maybe he really did have a vision and they had something to tell him.
Right.
And all of a sudden the world becomes a much more magical place.
Totally.
And it's not just these like folklorish,
that gives me
funny
shivers.
stories that people are telling in the form of religion that people think, it's just this sort of garden variety thing that you do, you show up, it's for the community, whatever. But it's ultimately, there's no metaphysical truth in it. And then there's science, which is like cold and amoral, but it's real somehow. This would marry those two things in this like freaky way.
It's amazing.
It would be kind of crazy, but I don't know if it's happening.
I think it's inevitable. It is
Yeah.
inevitable. There are too many anomalies that are being reported and that are being measured and observed around the world that for us to ignore, that relates to almost religious-like experiences, right? Like,
Yeah.
I think that it's it would be so painfully naive of us, and it is, to conclude that we know everything there is about the universe, or we're so close that we can say that there's no such thing as like, aliens, for example, right?
Totally.
Like, think about it, our quantum mechanics and general relativity, that describes 5% of the damn universe.
Yeah.
The other 95% isn't even describable with our physics.
Yeah.
Right?
Yeah.
And like, yet people are so damn confident about their worldview.
Yeah, it's crazy. I think they mistake the map for the territory.
It's because, love it. Yes, that's exactly it. That's brilliant. For
What
sure.
would you be working on if it wasn't quantum computing?
If quantum computers didn't exist, I would definitely be in artificial intelligence.
Do you think AI will ever get to a point where it's generative and a human doesn't need to feed it some ideal end state that it's sort of judging it on?
Yes. It will be when our fundamental machine learning models are better and improved and we go beyond the neural networks of today, and when they have their own physical body. Because that's what they're missing, is the ability to actually interact with the world around them.
Where I would disagree with like Elon Musk or Nick Bostrom or that camp of people is like they seem to have these like doomsday scenarios in their head that are like near term, where like these like sentient killer robots decide that human meat space is useless and or they don't fit into some objective function, and then we end up getting thrown out and killed. And where we are now, which is like statistics on steroids, to that just feels like this insane leap of logic. And I actually think the more insidious narrative is that AI is already killing us, but AI is just consumer apps, and consumer apps are eating us, our brains.
I think it's brilliant. No, that's a very, very wise insight, because most people who use TikTok, for example, right?
Yes.
They have no freaking clue how much they are being manipulated by an artificial intelligence.
Totally.
No idea the extent of it.
Why she ain't put the news at the bottom? Then that's disgusting.
So imagine, we already saw problems with Facebook when people were experimenting with Facebook's news feed to see how it affect people's mood, and then, alleged suicides and deaths would increase during this results of this experimentation. Right? How do we know that's not also happening with TikTok and other outlets and so on?
Yeah.
So absolutely, there's an insidious aspect of AI that we should worry about. That's outside of the.
I think so too. I think it's killing us with a whimper, not with a bang.
Love it.
It's
That's
just
so well said.
eating away at us, sort of parasitically.
Quantum computers in the next, let's say, to be conservative, 15 years, I'm being highly conservative there, will become powerful enough to completely make RSA obsolete. RSA encryption is the backbone of society, right? It's what allows you to securely access your bank account, to send messages on Facebook.
You could reverse engineer that with quantum computing.
Exactly. That will happen. It is not a matter of if, but when.
So you could double spend Bitcoin.
You could double spend. All of these, most of these cryptocurrencies today will become obsolete because of quantum computing.
Well, that's an interesting sort of black swan event around crypto.
It will happen, totally.
Yeah.
And it's a lot of people will get blindsided and caught blindsided in that. Absolutely.
Interesting.
Absolutely. And so what happens when there are nation state actors or people who are intelligent enough that can build quantum computers, and suddenly the whole world's information is exposed, right? What happens if I can read your Facebook messages now that you've sent throughout your whole life?
Right.
How disturbing would that be? So I think that event alone will force society.
It's the apocalypse.
Exactly.
Yeah.
Or like force us to work together, basically. Like, cause like everybody will lose their leverage, right? At the same time.
Yeah. Well, dude, thank you for doing this. This was a lot of fun. This
Absolutely.
was a blast. Yeah.
Likewise, Jesse.
Yeah, thanks, Deep.
It was such a pleasure, man.
Well,
We'll
you
do this
too.
again sometime. I
We'll
hope.
definitely do this again. Do it in Miami.
Absolutely, yes.
Watch more podcast clips now on our YouTube channel. Go to Livewire Podcast Clips and watch more great podcast videos just like this one.